Hello, our electrical engineers. Our topic of discussion for today and in preparation for the next step in our rover projects is to study about electric currents. And more importantly, can you engineer some circuits? So let's talk about electric currents and electric circuits, So this really handsome guy on the right here is George Ohm, and he did a lot of work with electric current, a lot of investigation and testing, experimentation, and he came up with what we now call Ohm's law. Now remember, the unit of measurement for resistance is ohms, and that's because it's named after him, because he found that the resistance in a circuit is equal to voltage divided by current. So here's the formula for it. Resistance equals voltage divided by current. But those of you who are pretty good in math, or even not so good in math, can see that you can rearrange that formula to be voltage is equal to the current in amps times the resistance in ohms. Now that's all kind of difficult to just look at the formula and go, oh yeah, I get it. So it's not necessarily easy to understand just by looking at the formula. But if you look at this is an interactive, and if you go on this slide presentation and you click on interactive up here, this will actually take you to a website that has this interactive where you can change the amount of voltage. You can play around with it, and you'll notice if you increase the voltage, the amperage or the amount of current increases. That's what's down here, but the resistance stays the same. So that's basically what Ohm's law says, is that conductors, which are the ones that we say have resistance, they're going to have constant resistance. It doesn't matter how much voltage you apply. So you can go up and down with the voltage here, okay, but the resistance of this wire, the resistance of that is going to be the same. It's not going to change. So if you want to go to that website, click on that interactive and go and check it out, play around with it, and see if you can understand Ohm's law a little bit better. All right, so circuit basics. You have to have three things to have a circuit. First of all, resistors. For example, you might have a light bulb or some kind of electrical appliance. In your project, it's going to be your motors. You need an energy source, a battery. You also will be using a battery. And you have to have conducting wire. For example, an electric cord with appliances, but you guys have the wire. You should all be pretty comfortable with all these, and remember, in order to have a circuit, electric current actually flowing through the circuit, it has to be closed, so when you open it, it stops. Now, a switch is not necessary, but it's a really good idea, because let's say that that you don't have a switch and you plug something in, it's going to run continuously until you unplug it, until you break that circuit. The same thing is true with your rovers. If you don't have a switch, you have to unhook the wire from the battery every time that you want to stop it, and you've got to hook it back up every time you want to start it. So a switch is not necessary for an electric circuit, but it's certainly a good idea. All right, then there are two main types of circuits that you guys are going to be practicing with, and one is called the series circuit. Now, the series circuit is quite simple. It really is just one loop in the circuit, but there are some disadvantages to a series circuit. So if one of your resistors or one of your light bulbs burns out, none of the other ones are going to work because it causes a break in the circuit. It's almost like you opened the switch here. Even if this burns out, then it's like you've opened another switch, so the current can't flow to the other lights. And then another thing is, the more resistors you have, for example in this one, the more light bulbs you have, the less current. So these the bulbs further along are going to be less bright. So that's some of the disadvantages of a series circuit. All right, the other type of circuit that we will be looking at are parallel circuits. Now, the main characteristic of a parallel circuit is that it branches. So if there is a break in the current, then if there is a break, then the current still continues. So for example, if one of the light bulbs, if this light bulb here burns out, the current is still going to be flowing through here, and it will light up this light bulb. And then also, even if you add branches, the overall resistance decreases. And so your light bulbs are going to burn at the same brightness. They're not going to be any more dim like in a series circuit. All right, so those are just the basics. You should already be a little bit familiar with those after our class activity the other day. We're going to do some more with that in our next class. And then also one activity that we want you to do is on page 180 and 181. It has a picture of a house and all the different electrical appliances and outlets and things like that that you might find. And we want to check your understanding of the different parts of circuits. So you're going to label those as a wire or a resistor or a switch or an energy source. And so you can take a look at that, and we'll do it in class together, and we'll talk about it, and we'll see how well you understand electric circuits. All right, so that is our electric circuit content. Quite easy. It's going to be a lot of hands-on in preparation for your rover build. So good luck with that.